Okay, we learned about reaction rates. Now we're going to learn about equilibrium. It's a very important topic that we're spending almost no time on. I'm crying a little bit inside. Let's all have a moment of silence. Okay, not too long, you'll fall asleep. Okay, what the heck's going on in this reaction? I have no idea. It's got pink, it's got blue. I'm going to come back to that later, if at all. Weird. Notice that the reaction equation above has a double arrow. Oh, yeah, I didn't notice that, but okay, it does. It goes in both ways. This reaction, like many reactions, can proceed from left to right. That's normal, right? Reactants used, products made, like we're accustomed to. However, this reaction can also proceed from right to left. Whoa! Backwards. Okay, so backwards, that would mean reactants are made and products are used. It's just the opposite. So it'd be going that way. Let me delete that arrow, that's obnoxious. Okay, when the forward and reverse reactions occur at the same speed, something called chemical equilibrium occurs. Because the forward and reverse reactions proceed at the same rate, any reactant used to make product is immediately used to make reactant, and vice versa. So the product is then turned back into reactant, so the overall concentration of reactants and products does not change. Okay, fill out these blanks before class. Now let me give you a demonstration. Let's say we have an equation, and it says that, okay, first off, it's an equilibrium equation, so it can go both ways. And it says that for every 2 squares, you get 1 circle and 2 triangles. I gotta make a triangle now. Triangle. Okay. And let's say we start off, and this is our little reaction area. And we start with, I don't know, how many squares do you want? Just yell it out. Did you actually just yell at your phone right now? That would have been interesting. People looking at you funny. You're like in the library. People are just like, why did you just yell 5? But okay, 5. And let's say we have, I don't know, 3 circles. And we have 4 triangles. Now what's going to happen is this square, okay, 2 of these squares, they're going to break down. So when those 2 break down, oh no, wait, let's back up a little bit. Okay, first off, how many do we have of each? We have 5 squares, we have 4 triangles, we have 3 circles. Okay, now let's do this. So let's use 2 squares, and when we use 2 squares, we know that we make 2 triangles and we make 1 circle. Just hold on if you're confused, okay? Just pay attention. And then we also know that the reverse is going to happen. So we're going to use up 2 triangles and a circle, and what we're going to do is we're going to make 2 squares. So now let's count this. We still have 1, 2, 3, 4 triangles. We have 1, 2, 3, 4, 5 squares, and we have 1, 2, 3 O's. So this is an example of chemical equilibrium. It's going back and forth at the same rate, and so nothing happens. Now you could do the same thing. You could have 4 squares. I could use up 4 squares. And that means I would make 2 triangles, and I would make 1 circle. But then I would have to use up 1 circle and 2 triangles, right? Because forward and reverse have to be equal to make 2 squares. And so it all is still the same amount of everything. So you don't always have to use only 2 squares. It's just these ratios. It has to go back and forth at the same speed. Okay, so bring your questions and your key points and fill these out. They should be already filled out for class. Bye-bye.